Hi everyone. So now we are going to start coding from scratch the cross-validation method. Also, we're gonna code the random subsampling. So yeah, let's start. So as usual, the first thing, I'm gonna use this file called classifier performance, and here I'm going to code the k-fold cross-validation class. So I'm gonna import numpy. Okay, so we will call our class k-fold validation, right? So our init function will receive the model, I mean the classifier, right? The data and some parameters. So in this case, let's assume as default parameter the number of folds, and let's assume that the default value is going to be 10 here. Okay, so self.model is going to be the model we receive, the data, same thing. Let's call labels the column with all the class labels. So we're gonna get it from the data. I'm assuming here that there's a column with the class and it's called that way. And the features are going to be all the other columns. And this is useful when we preprocess the data, or sometimes we need to iterate over the input variables. We need to know which columns are the features and which ones are the class. So let's use self.data.columns if f is different than class. Okay, so our first function is gonna be called getSplits, and is where we are getting the index that we are going to be using for testing and training. So let's use a variable called indexes that is going to extract them initially from the data, right? Sorry, also I'm assuming here that we are using a pandas data frame, right? So this is the syntaxes I'm using for that, and we're gonna use a dictionary to save the splits or the indexes of the splits, right? So let's say we're gonna have k items inside the dictionary. Let's initialize this as an empty array. These are indexes, so let's make sure that they are integers, right? And we're gonna do this range for in number of folds, right? Right, so if we have k folds, we are going to need k items in our dictionary, and the fold size is going to be, so it's first is the length of the indexes, right, divided by the number of folds. I have them here. We want to make sure that this is an integer, and it's going to be numpy.floor to round a potential float division, and we're going to cast this as an integer. Okay, we are using stratified sampling, so we need to iterate over every possible class, and we need to extract a given amount of entries to form the different folds, right? So first we are going to iterate over the classes. we use unique to extract all the possible classes in our database, and let's call this slice class. So here we are taking one slice. First here we're going to extract all the indexes that belong to the first class, right? So we're going to get all the indices where the labels are equal to this class in particular. So here we have, for example, if it's class 1, we're going to get all the indexes for the entries that belong to the class 1. Now, we needed the class proportion because we are making stratified sampling. And it is the length of this slice divided by all the number of indexes. I mean the amount of data points, right? So that's the proportion of the class. And now we need the number of samples. Let's call it S. And it's going to be the fold size times the class proportion, right? This is what we're getting. So this is the number of samples we are getting in this iteration. And again, we need to make sure it's an integer, and we round it down. Yeah. If you're not familiar with numpy.floor, take a look to those functions. It's basically rounding functions, and this is necessary to cast the type of the variable. Since we already know how many samples we are getting for this class in particular, now we need to iterate over the k folds, right? So we are iterating over the folds. We're gonna extract the indexes for this class and for this fold, right, by using numpy choice function from the random library. Okay, so out of the indexes that belong to the class, the size is going to be S, and we do not want to take this with replacement, right? We want to make sure that we are not choosing again the same entries. So now we have the indexes that belong to the fold K and the class corresponding to this specific iteration. So we need to add this to our dictionary. So we're gonna append what we have, right? We know we started with an empty item in the dictionary, but over the iterations we are going to be adding the indexes of the fold across the different classes, right? So we need to do this. And now we also need to make sure that this slice will not contain anymore the indexes that we already have chosen here. So it's going to be, I'm using this way of filtering. So here we're saying that now we are leaving out all the entries that we already selected for this fold in this class, right? And we're going to make sure that this is a numpy array, right? So now we need to return the splits. So again, remember here we are creating a dictionary with all the indexes that are going to be used for the different folds. And we make sure that we selected on every class proportionally to add those data entries to the given fold. So this is why we iterate over the classes, and per every class we pass over all the folds and there the amount of elements we want of that class inside that fold.